Okay, really quickly, Thursday. On Thursday, we saw what a sine and cosine curve look like. What a sine and cosine curve look like. And that's kind of weird because sine and cosine, aren't they from right triangles? Yes. But they also cycle, and they go from, for instance, sine goes from 0, right? 1, 2, 3. It counts up to 1. But then 0, 1, 2, 3 with square roots and over 2, yada, yada, yada. 0, 1, 2, 3, all over 2, 1. Then it goes 3, 2, 1, 0. Then it goes negative 1, negative 2, negative 3, all square rooted over 2. Negative 1. Then it goes negative 3, negative 2, negative 1, 0. If you guys think about it, it goes up, comes back down, goes negative, comes back up. Maybe it makes a little bit of sense as to why it's cyclic. That's exactly what's happening in the unit circle, just you don't see it put out on a graph like this where you have the angles going along the x-axis and the ratios going along the y. Cosine, very similar, but it goes 1, 3, 2, 1, it counts down. 0, 1, 2, 3, no, sorry, negative 1, negative 2, negative 3, negative 1. Negative 3, negative 2, negative 1, 0, 1, 2, 3. So it starts 1, and it counts down, then it goes negative, then it comes back, and then it goes positive. That's 0 to 2 pi, and then it keeps on cycling. So anyway, these are called, do you guys remember the names? Oh, it's at the bottom. How do you say that? Sinusoidal, right? Sinusoidal, the sinusoidal curve. Anyway, and we talked about how these can change. They can be stretched, they can be compressed, and we could do it with just the old-fashioned, hey, make it a stretch, but they're already kind of complicated anyway. So we're breaking it down. We're breaking down all the transformations that can occur, and I gave them special names on Thursday. Sinusoidal axis, amplitude, period, phase shift. Now, you guys have some little tidbits to explain each of these. First of all, amplitude. Why did I start with this one? It's the easiest. Because if they're waves, literally, sinusoidals, they're waves. Like if you were to drop a pebble in a pond and you were to like look at the ripples, they're little sinusoidal curves. Although they're dampening, aka they're getting lower and lower, smaller and smaller, until finally it just goes like it's smooth again, right? But coming back. Amplitude. How high? How low? Technically, half the distance between the maximum and minimum, but how high, how low? So, if I was to, now guys, hold on, help me out. Is this a sine or a cosine?
Cosine.
Sine. Why? It starts in the middle, right? It starts in the middle. Sine starts in the middle, cosine starts at the top. But how high, how low? It's half the distance. Why? Because with a wave, it goes up, and then it goes back down, and then it comes back to a resting point. How high the wave is only from the middle to the top, or from the middle to the bottom. Okay, so that's A, that's amplitude. Period. How long? It's a periodic curve. I'm going to use sine again just for sake of illustration. It's a periodic curve. The period, how long it takes to repeat, to have an entire cycle, right? So therefore, like a pay period, right? A pay period, if you get paid every 2 weeks, that's how long it takes until you get your next paycheck. Or if you're paid like once a month, that kind of stinky, but that's okay. It's how long until you get paid, right? So this one, how long, it's the x's, not the y. The y is how high. The period is how long. Now, if I have, for instance, it's starting at A and it ending at B, the period would be B minus A. It's the distance. The distance between the beginning and the end, which for a sine from middle, well, to middle, but at the end, it actually crosses 3 times. So it's the horizontal distance from the beginning to the end of one cycle. One cycle. All right, do we have those two? Amplitude, how high, period, how long. Translations, vertical shift. The easiest way to do a vertical shift is what you guys wrote down, to shift the sinusoidal axis. And the sinusoidal axis is going to be at y equals, now hold on, can we go back to our equation just for a second? Sinusoidal axis, what letter was that back here? D. Oh. So it's y equals, forget all the trig stuff, it's y equals the other number. That's where the sinusoidal axis is, so at y equals D. We'll get back to that. And I'll show you a picture of what he is and do some examples, etc. Horizontal shifts. Now, here's the dealio. Translations. All of these, shift, shift, both of these are translations. Sinusoidal axis is the vertical one, right? What's the horizontal one? The phase shift. The phase shift. Let me try to do an example of that one. We were talking about like pay periods, right? Okay. Let's say you get paid every 15th of the month. Or let's say you get paid every other Monday. Would that be a difference as to when you get paid? Or every other Friday? If you get paid on Monday, that's different than getting paid on Friday, right? If you get paid on the 15th, that hits different days of the week. So it's different when you'll actually get the money. Phase shift, it's like the beginning. When does each cycle start? So it's the shift 4, the horizontal shift 4. We're going to find the beginning of a cycle. We're going to find the beginning of a cycle. Technically, the phase shift is going to be at, and you guys already wrote it down earlier, at x equals, let's see, what was that letter? Phase shift. Here he is. X equals, depends on how you write it and which form is given. Remember, one of them might be given, but we really want it to look this way. The phase shift is going to be this little number right here, x minus, which we're used to, but we can't have b next to x. He has to be outside. So we'll say x equals c over b. But hopefully we'll just kind of get used to that so that we're not really stressing about that division. Because it's not so much a division that we have to do, it hopefully should just kind of work itself out and steal the number of whoever it is. And one more quick reminder, since we're talking about the beginning of a cycle. Remember, sine starts in the middle. I'm going to put a little line here and say y equals d. Sine starts at y equals d and goes up and then back again. Cosine starts. Let's see if this makes sense. Y equals d cuts this in half, the sinusoidal axis. Cosine starts at d plus a. It's not on d. It's up a, or the amplitude, away from that. So, sine starts in the center. If you want to think of it that way, sine starts in the center. S with S, even though it's a C. It's rough because then cosine. But help, sine starts in the center. Cosine starts up top. Okay, that brings us to him. Have you guys ever seen anything kind of like this little dotted liney thing? Going back to elementary school. You know what I'm talking about? Yeah. Remember how you used to have those handwriting and others?
Oh yeah,
Yeah.
the cursive practice.
Right?
Oh my gosh, throwback.
You had to like connect them.
Yeah, I'm so good at
Okay, that's exactly what we're doing, but we're not filling in letters. Guess what we're filling in? Sinusoidals.
What? Oh, great.
We're filling in sinusoidals. Because they're waves, but they're waves with set heights, set lengths, etc., etc. To be honest, the amplitude is going to be the easiest part. It's where to put these handwriting lines in a graph is going to get a little tricky, and then the trickiest thing is how spread apart, how wide they're supposed to be. But I'm going to show you a few things, all right? So, when I talk about the sinusoidal axis, I'm talking about the center. When I'm talking about the sinusoidal axis, I'm going to mark it as SA. When I'm talking about the sinusoidal axis, I'm talking about the center. What the wave circulates around. If you want to think of it, what the level of the water would be before the pebbles dropped in. It's just like the smooth, the calm, the initial, the equilibrium, right? That's the sinusoidal axis. But then depending on what you have, let's do sine first. depending on what you have, first of all, this D could be somewhere else besides the x-axis. It could be like up or down somewhere. But you're going to have a sign start. I'm going to go ahead and go down here. Let's say C over B. Sign's going to start in the center. Then you're going to have to figure out what we already talked about. You're going to have to figure out how high and how low. There's your amplitude. Stealing right out from here. So we've dealt with D, check. We've dealt with A, amplitude, how high, how low. So we're going to put our upper bound and lower bound to our handwriting lines. We're going to be writing the handwriting lines ourselves. Then we're going to have to figure out our period. Now here's what gets a little tricky. We're going to have to figure out our period. Actually, let me go ahead and mark this as red. It's not particular to sign. Our period tells us where to end, which for sign, it starts in the center and it ends in the center. It starts in the center and it ends in the center, but in order to get over here, we're going to have to go ahead and do C over B plus the period. And the crazy thing is the period is a little bit complicated. The period is 1 over B times 2 pi. 1 over B times 2 pi. It's a little bit rough. But then once we get who the period is, 1 over B times 2 pi, I'll write it again down here with period. We add that to the initial point. We're going to cut this into fourths. We're going to go halfway, and then halfway, and then halfway. Ooh, pretend that's even. And once we get the halfway, 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 we can come up and say, okay, that's the middle. That's the middle of my graph. That's one key point. This one's going to be the tallest of the wave. That's another key point. This one's going to be the bottom of the wave. That's another key point. And as soon as we have all of this put together, all we have to do is stay within the lines. Stay within the lines. For cosine, the only thing that changes, all of the other work stays the same. The only thing that changes is, instead of starting in the center, you start up top. 1/4 of the way, you're going to be in the middle. 1/2 of the way, you're going to be down below. 3/4 of the way, you're going to be back up. And at the very end, you're going to be back to the top. So cosine, the nice thing is there's not really anything super special about his process. Oops, stay within the lines. His process is the exact same as sine, which is really, really nice. It's just that his points start in a different place. Now, this bottom part, sorry, it might have been a little hard for you guys to see. Once we do find the period, we just start from the phase shift and go quarter cycles for each of our key points or our key numbers. But those are the points that I marked. Now, this is all well and good. Tons of theory. The problem is we haven't actually done a full example with all these different, there we go. With actual numbers in these places instead of just D's and A's and B's and C over B's. So let's go get ourselves an example, okay? A couple seconds more. So D, where's the middle? A, how high, how low to make the upper and lower handwriting lines. C over B, sweet, whatever X value we start at. Period, You can't steal period from any of these numbers, but we use the B and plug into the formula 1 over B times 2 pi. Now guys, let's go back to that clue real quick. Where's that period? There he is. Let's write in that formula right here. Let's write in that formula right here. It's a super important one. If you think about it, normally sine and cosine cycle every 2 pi. Normally sine and cosine cycle every 2 pi. And so if there is a horizontal dilation, it's backwards what I think. It's the reciprocal. And so we take the normal period, 2 pi, and we multiply him by 1 over b. We're doing what the math would tell us to do. This is going to be a dilation. It's going to be a horizontal dilation, but remember it's 1 over. So 1 over b times 2 pi. We're just following the math. Okay. I don't like any of these. Hold on. I'm going to change him. That's yucky. He's not hard enough. Maybe that's not a good way of putting it, but he doesn't show you all of the pieces very well. I don't know why I haven't changed this in the past. Fun. Okay. Let's make him -2 plus 3 sine of 1/2 x plus let's do plus 1. Let's not do plus 1. Let's do plus. Okay. Kiddos, can I have you go back to where we first wrote? Remember where that yellow asterisk was? Yeah. Can you peek at this and tell me whether this is what we're given, or is this the form that we want? Do we want this form? Remember there was a given form and a want form? Is it already written the way we want it, or no? No. No. What's the problem? Who don't we want? We don't want the 1/2. We don't want it in there. So in order to start this entire problem, we need to go ahead and write him in the form that we want, okay? So I'm going to go ahead and rewrite him. What are we going to do with that 1/2? Take it out. Here's the struggle. We need to figure out when we factor him out who's left inside, right? We took him away from the x, so the x is still there, plus. What number are we going to have inside?
4.
Which one? 1 or 4? If we put a 1, does that work? No. Why is Sean saying 4? Half of 4 is 2, but how could you do the math? Remember, when you factor out a 1/2, you divide. What's 2 divided by 1/2? Ooh, what's 2 times the reciprocal of 1/2? 2 times 2 is 4. Okay? All right, now this is the form that we want. I'm going to get my little highlighter out and say, you know what, now we're good to go. Now we're good to start. This is who we want to look at. Now, we need to go ahead and compare him to the whole A, B craziness that we have. So let's go ahead and start with, let's see, where was our handwriting line? There they were. Let's start with red. All right, here's our sinusoidal axis. -2. This is where we always start at the very first problem, okay? -2 is our sinusoidal axis. What does that mean? It's the middle. The vertical shift says go down 2. This is the middle of our handwriting line. Remember, we're making the handwriting lines ourselves for our waves, for our sinusoidal curves. So we have the middle line. Those of you that are a little OCD, you're like, some of your dots are longer than others. I know, I apologize. Okay, got it. Sinusoidal axis, guess what? Check. Y equals -2. There's our sinusoidal axis. Okay. What's the next piece? That's number 1. Number 2, let's go amplitude. Okay, how high, how low from -2 are we supposed to go? 3. So we're going to go up 1, up 2, up 3. What am I making right now? The top of the handwriting lines, right? But what other direction am I going to have to go? Not perfect, but is that all right? Okay. have we shown the middle of the graph to be down 2? Yes. Have we shown the height and the depth of the graph needing to be up 3, down 3? Yeah. All right, sweet. Well, guys, we got that one. We got that one. Sine. Okay, sine. We need to think of sine as
Starts in the middle.
starts in the center. But wait a minute.
Starts at x equals 0.
Starts in the middle. So y equals -2. Do you mean how high?
No.
Oh.
Yeah,
Okay.
but it
We
starts
need to
in
know
the
2
x-axis.
things. We need to know how high does it start, -2, in the center. But we also need to know how right or left does it start. Oh, stink. Well, how right or left? It usually starts at x equals 0, but the problem is we have to ask ourselves the question, has there been a phase shift? Look at your little formula, phase shift. How do we get a phase shift?
X equals CV.
Uh-huh. Do you see a number in that little spot? I do. Okay, so there's going to be a phase shift. I'm going to start. This is what the phase shift means. Start at x equals, okay, struggle. Isn't it x minus c over b? Or x minus h? So I'm going to not say positive 4. I'm going to say negative 4. Yeah? I'm not going to say positive 4, I'm going to say negative 4. So let's go ahead and say,
Is that
struggle.
equal that to 0? Yeah, x plus 4 equals
Yeah.
0.
Yeah, we could do that. So then we're going to go 1, 2, 3, 4, negative 4, yeah? What does that mean? That means this is where I start in the center. Where? Where it's supposed to start. At the beginning of the cycle, at the phase shift. So I'm going to start at x equals -4. All right, cool. Now I need to go ahead and, well, how long do I make it last? Like, I could just randomly do a curve right there. I could do a curve right there. Like, how do I know? I need one more clue. What's the one thing we haven't used yet, guys? All right, we haven't used the sign yet. Oh, you guys said sign. Sorry, I thought you were going to say, and I just copied you. No, what other thing haven't we used?
The half.
Sign, we started in the center. We technically used sign. But we haven't used the half, right? We haven't used the half yet. I know it's going to be annoying, but I'm saving the green for cosine. Okay.
What color is it?
I don't know, tan. Okay, so keys B. What's the one piece that we haven't done yet that's marked on the other graphs? Period. Oh, okay. Period equals 1 over. Wait, 1 over, isn't that reciprocal? What's 1 over 1/2? 2. Okay. 1 over B, which is 2, times who? Ugh. I don't like that. But either way, oh well. What's our period?
Oh, but if the 2 pi, if in 2 pi we go only 1, now we go 2 because of,
We're going around twice in order to get one cycle of this weird transform thing. Gotcha.
yeah, but what I'm saying is, remember when we go 1, 2, 3, and then like 1?
Right, it's not going to be the same because remember all of this is messing up the numbers we're putting in. Yeah, so it's going to take longer. Now hold on, wait. What is 4 pi?
Twice around.
Well, like as a number, just so we have like a reference because we have 4. It's around 12. Let's say 12 and a half-ish. Okay, so if it's 12 and a half-ish, thank you. Do that. 12 and a half-ish. Hold on. 4. 1, 2, 3, 4, 8. 1, 2, 3, 4, 12 and a half-ish. Does that sound about right? So we'll go 4-ish, and then we'll go 8-ish. Remember, so we're going to have this 4, that 4, that 4. That's 12 and a half-ish. Okay. So we'll say that we're supposed to end about here. This distance is supposed to be 4 pi, right? because of up there. Hold on, what are we supposed to do? We're supposed to cut this whole thing into what fractions? Fourths. Oh, well, what's half a 12-ish? 6-ish. Now we're going to be approximating, right? But 6-ish. Okay. So let's count over 1, 2, 3, 4, 5, 6. Well, okay. 6-ish. Well, hold on. We want to go half and then half again, right? So let's not cut it into fourths. Let's cut it. No, sorry. Let's not cut it in half. Let's cut it into fourths. How much distance would it be if we did a fourth of 12-ish?
3.
3-ish. Okay, perfect. So ready? For our sign, we're going to go 3-ish. So 1, 2, 3-ish. I'm going to do like little decimals. Is that okay? Why am I marking a point after 3-ish way up here?
Because it's a sign. No.
Yeah, because it's a sign, and so where's it going to go? Up.
First and then.
Exactly. So after 3-ish,
Sign, it goes down.
if it's a negative sign, yeah, it'd be flipped, and so it'd go down instead. But since it's a positive sign, see this little positive sign? It's going to be the normal way. So it's going to go up first. Let's go 3-ish again. 1-ish, 2-ish, 3-ish, a little bit more. Now it's in the middle, right? Does that make sense? Because I went to the top, then I went to the middle. I need to go 3-ish again. Oh, my tick marks are a little off though, huh? 1-ish, 2-ish, 3-ish, and a little bit more. Isn't it now at the bottom? And then a 1-ish and a 2-ish and a 3-ish and a little bit more. Now it's at the center again. And then you say, stay within the lines. A little bit off.
You should just do a little bit more because it's pi.
It is high, yeah, so it's 0.1. Now we approximated. But do we have the main idea? Yeah. If we wanted to be super specific, I guess we could go ahead, and this was our 1/4-ish, 1/2-ish, 3/4-ish. We could get out like rulers and graph paper and all that sort of stuff, but if you guys are okay not doing that, let's not. Do you see how all the pieces went together? Can we really quickly just go through the order though? What's the order of graphing? Just to help us out. So we're going to go back to this page real quick. What was the first thing we did? Okay. Let me get my little yellow pen out so that way we can know it's something different. The first thing we did was the sinusoidal axis, right? That was the first thing, D. What was the second thing we did? Remember? We got the center line, then what? Okay, then we got the other two lines with amplitude. So the second one is amplitude. Okay, what's the third thing we did?
Where we start.
Where we start. So we looked at sine or cosine and we asked ourselves the question, where do we start in the sense of center or top? But we also had to ask ourselves, wait a minute, literally, where do we start? Literally, phase shift. We don't know how to start drawing our graph if we don't have a starting point. And then what's the last thing that we did? We figured out our period, how long it was supposed to last. We used B. It wasn't B. Remember, it's 1/b times 2 pi. We had to use a little formula. And then, last but not least, we marked our little key points. And we connected, staying within the lines. So, sinusoidal axis, number 1. Amplitude, number 2. Starting point, well, what's the shape? Number 3. Starting point, number 4. How long do we make it last? Number 5, and then connect it all together. Now, we did one example. Oh, we're still counting, sorry.
The 4 is like, okay, we know it's going to start either in the top, bottom, or middle. 4 is like the point where it's
Literally
going to
the
start.
X.
Okay.
It's literally the X. Alright, let's do another one. Okay, ready? Step number 1. Where do we start? Careful. Sinusoidal axis. Uh-oh. Wait. Where's D? Okay, hold on. Is this in the form that we like? No. Alright, so hold on. why am I going to write it 0 minus 3 cosine? Why am I putting a 0 in there?
So we see the D.
So you see the D, yeah. Okay, who do I need to pull out? Who's with the x I don't want?
2 pi.
Okay, pull out the 2 pi. And I get x plus 2, right? Is that okay? Now we start at our sinusoidal axis, true? Has this been shifted at all? No. So where am I going to put the center? At y equals 0, or on the x-axis. Perfect. Step number 2. How high I go?
-3, so it goes 3 up and 3 down.
Okay, so I'm going to go 3 up. And 3 down. Doesn't even. Okay, 3 up, 3 down. Check, sinusoidal axis, amplitude. Okay, now we ask ourselves the question, who is this?
The cosine.
Cosine. Cosine starts at the top, and then he goes down, down, up, up.
But it's negative.
Top, middle, down. Now, that's how cosine normally works, right? Start at the top, middle, down, middle, top. Now, Luca's like, wait a minute, but there's a minus. Doesn't that change stuff? We have to look at both pieces, both who the trig function is and whether it's a negative. Why? When you multiply by a negative, do you remember what happens? A negative on the outside.
Flips.
Oh, so instead of like being a hill, valley, hill, what's it going to be? A valley, hill, valley, right? Oops, I forgot my little points. Little points there. Okay, it's upside down. Has to be flipped. So we kind of had to change that. So you have to look at the sine or cosine and look at the sign. S-I-G-N. Positive or negative. Okay. Who is next? Ooh, purple, right? Skip over the 2 pi. We don't like him. He's hard. Ugh, all right. This is our C over B. This is our starting point, right? Where are we going to start at? Good. Start at -2. So we're going to go 1, 2. Now, how do we start? Bottom, right? Not center, it's not sign. And it's going down because it got flipped. So we're going to start at the bottom. Oh, but we can't make our wave until we know how long to make them. We should naturally just get to this disconnect and be like, I don't know what else to do unless I look at my last number. Look at that weird brown tan thingamabob. Where's that weird brown tan? There it is. Okay, we're going to use the 2 pi, right? What does period equal? We have to use it. That's not the answer. How do I find period? 1 over
2 pi.
b times. Oh my goodness, what's the period? Oh. Wait a minute. So I need a whole cycle in that one? Yeah. Look, do you want to fit one in the whole cycle? No. So hold on. Let's go ahead and put -2 a little bit more this way. Sometimes you have to adjust a little bit and say, I don't think I planned this out so hot. So maybe it's better to find all of your clues and then go putting them in because we need to make -2 be a bit further away. But we could go by, let's see, halves? Yeah, that sounds good. So this is -1. Half. -2. We could do that. Does that give us a little more room? We could do it to give us a little bit more room, but that's okay. Let's go ahead and go get that yucky tan color. Alright, we need to fit a sine curve in that whole space. Oh, he's been a little condensed, right? Huh?
I mean, why are we going?
Because it's x, remember? Find the 0. -2.
Yeah, we're starting -2, but why? Oh, the period is 1.
The period is 1, so that's all I have.
And can we ever get period equals a negative number so it goes?
No, Because a negative would just be a flip. So we have a half. Uh-oh, don't I need to go by fourths too? So guess what? I'm going to go by, there's -1 3/4, there's -1 1/4. Why am I doing that? Because I need to mark all my key points. Remember, cosine starts at the, for this one, a negative cosine starts at the bottom. Then, middle. Oh man, this is squish. Then, top. Then middle. Then bottom. Hey, if I have tons of room, can I go again? We go middle, top, middle, bottom. Long story short. Wait for it. Have I squished him?
Yep.
Yep. Is he right? Yep. Now kiddos, here's what I want you to do. We have a couple homework helps. So here's what I want you to do. Do the best you can on homework. We're not going to grade the evens tomorrow, but we're going to do a few examples, see if that helps, but I need to know where you get stuck in homework. Sound good? Okay. You got to work on 4, 3. 4, 4, 5. 4, 5, 4, 5. Got to work on 4, 5.
Oh yeah. I'm not gonna lie, I guessed in one of them.
Just
That's
one?
Yeah.
Cheater. I'll have to guess.
Bye.
Bye. Bye, see you later.
Is this for me?